This is episode number 658 with Brian T. O'Neill, founder of Designing for Analytics. Welcome back to the Super Data Science Podcast. Today I'm joined by Brian T. O'Neill, who founded and runs Designing for Analytics, a consultancy that specializes in designing analytics and machine learning products so that they are yearned for and adopted by users. Brian also hosts the Experiencing Data podcast, an entertaining show that covers how to use product development methodologies and UX design to drive meaningful user and business outcomes with data. In today's episode, Brian synthesizes the most critical information from his 100-plus podcast episodes to fill us in on what data product management is, why so many data projects fail, how to develop machine learning-powered products that users love, and the teams and skill sets required to develop successful data products. All right, let's jump right into our conversation. Brian, welcome back to the Super Data Science Podcast. Kirill, the host of the show before me, had you on in episode number 353. It was a great episode, but it was also years ago, and we needed to have you back. Brian, how's it going? Where in the world are you calling in from?
I'm still in Cambridge, Massachusetts, People's Republic of Cambridge, as it's called sometimes. A little less COVID going on. That was the deep COVID, like when we did that show, I remember.
Oh, really?
So things are a little better in that regard.
I'm delighted to hear that. And so we were introduced to each other by Tom Davenport, who was a recent guest on the show. Mm-hmm. So he was in episode number 647. And as with many guests, at the end of filming with him, I said, Tom, you've been an absolutely A-plus amazing guest. Who else do you know is an A-plus guest? And he right away said Brian T. O'Neill. And I immediately looked you up, loved what you had going on, asked you to be a guest on the show, only to later discover that Kirill had already had you on the show. But it doesn't matter because you're a fascinating person, and I'm going to be asking different questions anyway.
All right, let's do it.
So you've been leading Designing for Analytics. It's your firm. You've been leading Designing for Analytics for 25 years. So Designing for Analytics is focused on making data products successful. So first, let's define for the audience what a data product is.
Sure. Well, first, I just want to correct that. I think that came from LinkedIn. So Designing for Analytics is my new consultancy. Well, newish. It's about 6-7 years old now. So I've been doing design consulting for 25 years. I changed my name and I formally focused in the data space, whatever that was, 6-7 years ago, something like that. Since I had kind of been naturally doing it with just the clients and projects, and even before when I had W-2 employment jobs, I had been doing a lot of this kind of work. So I put an intention behind my focus back then. So I just wanted to correct the record on
so
that.
We could say
Anyhow.
Designing for Analytics with like capital letters has been happening for 6 years, but
Correct.
Designing for Analytics with lowercase letters has been happening for 25 years.
Yeah, along quite a while. A lot of stuff with data. Yeah. So, but what was your second question? Sorry, now that I've
it was, what is a data product?
Oh, what is a data product? Tom doesn't totally love my answer to this, and I understand why. But I'm going to give you what I call the producty definition, which is not like there's some other definitions that are out there. But the way I kind of think of this is it's a full end-to-end human in the loop decision support solution that's so good somebody might pay to use it. And the important part of it, this is not a perfect definition. It will not capture all solutions. The most important part of this definition, I think, for data professionals who are maybe hearing about data products and this idea of product orientation, the most important part of this definition to me is the last part of this definition, which is the so good that somebody might pay to use it. So what do I mean about this? If you look up like a definition of the word product, we might think of product as like, it's the byproduct of labor, right? It's the thing that comes out of some labor. That is absolutely not what I am talking about. That's called an output. And I think the data community is really good at generating technical outputs. What I'm talking about is something that could be traded. It could be bought and sold. It has inherent value, where value is a subjective thing in the eyes of the beholder. And so even if you're working internally, like let's say you work at a bank and you help the fraud department and you build risk models or something like this, someone in that like risk department probably, maybe their compensation's based on like how much risk they cap or how much they prevent, the bank from losing money or something. Something's on the line for them that's high value. And maybe they actually are funding projects with funny money between, within the bank and all this kind of stuff, right? The important part here is like, it becomes a product when it's so good that they would pay to use it, or they would give something up of value. It's indispensable. It has some quality attribute that is in their eyes and not ours. It's not about how accurate a model is. It's not about how cool the dashboard is because it uses violin charts or whatever it may be. It's all subjective from the them perspective. And that's the producty mentality that I'm trying to push with this. It's not about it's not really about the amount of effort that went into it or which kinds of tools and technologies went into it. It has nothing to do with that. It's human in the loop because the other side of this is like Tom was talking. He's like, the one thing I don't like is like this excludes automation, for example, solutions that are running fully automated. In my opinion, there's not a lot of solutions that are entirely fully automated that never have any humans. Like, what about model drift? What when things go off the rails? What happens when COVID happens? All of a sudden, there's humans in the loop again, right? So there's that whole side of it, but there's also the who are the stakeholders or the sponsors or the third party affected people that may not even be in the room when the thing is made. But let's take like your bank, another bank example, like the getting approved for credit, a line of credit, right? Some customer on the end who was not involved with building the model that decides whether they get a mortgage or not. That's a third party. All of these comprise humans in the loop. From a design, when we talk about this from a design standpoint, these are all humans in the loop. So there are humans in the loop, even when the system is fully automated, because the business is humans. The customers are humans. The customers are not machines. The business is not machines, at least not yet. There is no, that this business is sometimes talked about this entity, like it's this separate organic thing, or it's a machine or something. But ultimately, it's John and Jane and whoever in some department. That's quote the marketing business, and then their teams, et cetera. So that's why I think humans in the loop is an integral part of this. Anyhow, that's my definition.
This definition, it makes perfect sense to me anyway, especially from the UX perspective that you're taking here. It's
sure.
like, there's a human with eyeballs on a screen probably who's interacting with this product.
Correct.
And in the background there are data or data models that are allowing aspects of the product to function.
Right.
So lots of different ways that data or models could be involved in products. So how do you bridge the gap between just having, like you said, that lots of people, like data scientists like me, get super excited about, this amazing model. Wow, look at this crazy thing we're doing. Look at how accurate it is. How do you bridge the gap between me being excited, the us and them thing that you were talking about there, Brian, me being excited about this data science capability, and somebody out there being so excited about this capability that they're willing to pay me for it? How do you bridge that gap?
So are you saying that the gap is that when John likes it, it's inherently not something yet that the customer likes? And then
I guess so.
Or not you, but whoever.
Yeah. So I mean, I guess the way that I stated that question, I guess it doesn't automatically assume, like, your premise, the premise of your company and your expertise assumes that there are situations, and from my experience, a large range of situations, where a data scientist or machine learning engineer creates an amazing model and people don't want to use it. So how do...
Hey, it's not my studies that says that. It's all the other studies out there that say it. And it's time and time again, there's been repeated studies about the problems of these we're standing up giant data infrastructure. We as Mark Madsen calls it, intergalactic, data systems in order to stand up potentially usable things in the future. And so a lot of these projects become, what's our strategy? We're moving to Snowflake. We're doing data mesh. That's the strategy. And it's like, that's not really a strategy. There's no defined outcomes. There's no definition of what done is. And done meaning qualities, OKR, like metrics, KPIs that have changed. That's all about building technical infrastructure, which, yes, I understand that's part of it, but that's all just inputs. That has nothing to do with outcomes, right? So, yeah, we go a lot of different directions here, but this premise that low adoption is a problem is something that's been quantified quite a bit. So, and the problems with low adoption can range. They can be all over the place, from the problem is not well defined, which I think is quite frequently a problem. And I think one unique thing that data scientists, and maybe some of your listeners have probably heard this, is that what the data tennis game happens, I call it. And this is when, well, what's your business problem that you need help with? Well, we want to use machine learning, but what could we do with this data? Well, what are you trying to change? Like, what's wrong? Like, what are you trying to do? Well, we want to know how machine learning can help us do something. And so we're hitting the ball back and forth, and no one is stating what the problem is. The business thinks you're going to help me figure it out. That's what you're here for. And the data science team is like, no, I'm here to build models and predictive intelligence and help us solve problems that are really complicated. But I need to know what's wrong before I can do anything. So then you get this question, well, whose job is it to surface the needs and the problems? And you can turn that into a role, or you can decide you're going to take ownership of that because you get tired of building stuff that doesn't get used. I think there's definitely a class of data scientists that are still happy to work on technically right, effectively wrong solutions, which you can write a paper about it. There's high predictive accuracy, maybe some unique technical aspects, but the model sits on a shelf in GitHub. It collects dust. It doesn't get used. And the feeling is that's not my problem, that they don't know what they want to do or how they have no plans to operationalize this. I hate that word. I don't even like using it. The designer's way of thinking about this is, no, the operationalization of the model is part of the design of the system entirely. You don't do that afterwards. It's not phase two. The operationalization, the usage of the thing is designed into the solution from the beginning. That's also just a product idea too. It's outcomes over features, right? It's not about building the things. It's about generating better future states for the people that we're here to serve. So you can either decide that it's someone else's job to figure out the problem, or you can jump into that role. You can ask for help. You can hire data product managers, which I think are ultimately the people that are going to own that response. You have to do that kind of work if you're really going to be doing data product management. That effectively is your work, right? It's to figure out what is the value that we're here to provide against the problems that we have surfaced. And I say surface because they're usually not on the surface. Data scientists, particularly, you're going to get a lot of what are called presenting problems, right? We need to use deep learning to do X. And your audience probably has no idea what they're talking about. I'm sure some of the people are laughing right now because you've had this conversation. Or we need to use k-means clustering. We want to use k-means clustering to fill in something where it's not appropriate to use k-means clustering. But so you can laugh at that and say they have no idea what they're talking about, or you can look at it as, this person is actually reaching out to me and they're trying to talk my language to help me understand what it is that they want. I get the same thing as a designer. When people come to me, it's always, the dashboard needs to be redesigned. The dashboard needs more, the charts need to look more like, what if Apple had done it? It needs to look like the iPhone. This is the designer's equivalent to what I know the data science community hears a lot too. And I used to roll my eyes and okay, whatever. And now I know it's that's just it's an opening line. It's just the opening thing in our little negotiation, the dance that we're going to do. And I know deep inside there's actually a real need behind that. And so my job is to get in there and to ask good questions. And this is really good too for introverts. And I think my general feeling after several years of this, because my own audience is very quiet, is that there's a lot of introverted data professionals. You don't have to talk a lot. You actually can just do good listening and ask good questions. And by asking good questions, we can start to dig into really what's behind this person who wants to use k-means clustering to do whatever. And maybe that's a right tactic, and maybe it's not. And maybe that's the 9-month version of a project that could be done in 1 month, but they don't know the 1-month version and you do. And maybe it's only 70% accurate, but that's $1 billion in cost savings and 8 months faster. And so your job really isn't to give them k-means clustering unless that actually aligns with what the real needs are, which are not on the surface. They have to be surfaced much of the time. And so this is kind of actually normal state, I think, for people with product orientation. This is all normal state. We hear this stuff all the time. People aren't really good at like having this omniscient view of their own problem space. I mean, I was talking to someone, who was I talking to about, oh yeah, I'm going to have this guest on my show to talk about building data products about reducing bias in models where the customers are data scientists. So we're talking about building tools for people who are generally pretty confident in their intelligence. That there's a sense sometimes that, oh, I don't need it dumbed down. I don't want it too simple. I've heard this for my life, designing for options traders and finance types. Don't take anything away from me. Don't take my data away from me. But data scientists too have jobs to do, and there's busy work if you've spent time building pipelines or just trying to get access to the data set to do all the stuff you were trained to do, all that stuff. That's all tool time and stuff that you didn't, that's not really what you're there for, right? That's not your magic zone. Good design can eat all that stuff away. And in the same way, you can be trying to take off that kind of busy work stuff from your customer, your business sponsor, or whatever, to help them get the thing that they want. But they're not going to tell you what that is on the surface because they can't. Most of the time, they haven't thought about it that way. They probably don't know how to measure it yet either. And I think data people can ask the right questions and probably could suggest how to measure it. But it's like, well, when do you want to get a reduction in risk? And by how much? And like, well, how are we doing right now? I have no idea. Then how do we know it's wrong? And then you find out, well, someone yelled at me. Okay, now we have something. Someone's angry about X. Well, why are they angry? Well, we lost $2 million because this model went off the rails. Oh, okay. Now we're getting somewhere. You got to kind of do that dance. It's called laddering when we ask the 5 whys. There's different language to it, but asking why, and you keep, we call it laddering up until you kind of hit this nugget. And it could feel weird doing this kind of work because you feel like you might be nosy or I'm challenging leadership or something like this. And I can guarantee you, if you do it in the right way, in a genuine way that's about serving, it's not about pointing out someone's faults, but it's like, I want to understand it because I don't want to waste your time and money. I don't want to go build the wrong thing. This stuff is hard. It's not guaranteed to work, and it can take a long time. So the more I understand what's behind your ask for k-means clustering, the faster I can come back with something that will serve you. It's a gift.
Yeah. So on one side of the equation, we have users or senior stakeholders who have some idea in their head of some functionality that could be better if data or data models were involved. And then on the other side of the equation, we have data scientists who can implement these problems, but maybe don't always know the right questions to ask. They don't ladder. They don't go into the 5 whys.
Yeah.
They don't understand what the core need is. So the data scientists end up building something that is roughly, it is the deep learning model, but it doesn't actually solve the problem that the user or the senior stakeholder came to them in the first place with. So it seems to me like a key role for bridging those two sides of the equation would be a data product manager. Yeah. So what's a data product manager, and how does that role differ from a standard product manager? Like, is there some kind of skill set that a data product manager has that a product manager doesn't have?
Well, yeah, and I don't think there's a great singular definition for that. I think, obviously, with the data product management space, there's this assumption that there's this underlying foundation of ingredients, which is going to be information, and that's going to be part of these building blocks of whatever it is that we make. I think a lot of the day-to-day work doesn't necessarily change from product management, except that like in your, your non-digital native companies, the product may not be sold, right? The product may be something for internal use. The same mentality, though, can be applied to these internal works, even if they're not going to pay for it. If you approach it as if our salaries depend on this, the business depends on this, and set the level of quality such that we want to be not just doing okay, but ideally delighting people with the work that we do, and set the bar at a quality where, again, that's measured and it's subjective based on the eyes of the person it's for, not us reflecting on our own work. That can still be applied there. And this is just very different than a project mentality, because a project is kind of like, I've assigned the parameters, they fit in a Jira ticket. Here's a definition of done. And it's like, we have no idea who asked for this. We don't know what department's going to use it. We don't know what engineer's going to implement it. It's just like, done. And at some point, yeah, there are going to be technical delivery points that happen in any kind of technology. We're still talking about software at the end of the day. We're still building software of some kind, right? But a product is actually kind of a never-ending game. It's kind of like reduce risk for the bank. Does the bank ever not have risk? No. So that's actually it's just never-ending game. And so for leadership, part of this idea, and Manav Misra talked about this, I interviewed him, he's the chief data analytics officer at Regions Bank, about how he had to help get management to think about funding these initiatives as kind of ongoing games, right? Like there's always going to need to optimize marketing spend, or again, reducing risk for the bank, or whatever it may be. They don't really end, right? So it's really a matter of like, this is always going on, but there's going to be milestones, which is like, this quarter we have this objective around risk. It's still under this overall thing of risk management, but like this quarter it's about X, Y, and Z, and another producty way of thinking about this. And this is, a lot of software companies are still maybe not doing this yet. Marty Kagan talks about this, but it's about assigning ownership of the problem space to the team and not the solution space. So the team, which to me, the classic trio is someone in this product management or data product management role, someone in a user experience or design role, whether or not it's actually a designer, it's someone that has some responsibility of, maybe it's a BI developer, a dashboard developer, but somebody who has some responsibility for what the end people are going to interact with. You have a software engineer who's going to package up the solution into whatever it's going to be. And the fourth role, I think, especially for data products, is going to be a data scientist or some relevant data professional on that. But the idea is that you take this power trio or power quartet and you assign them the ownership, which is like, hey, the bank needs to reduce risk by this much. They have an itch about fraud claims, or they have an itch that there's lots of, I don't know what it is. There's ATM fraud. They think something's wrong there, and we could have less ATM fraud. I don't know what it is. I'm just making something up. We don't know exactly what's wrong, but we want to reduce this by 50% next quarter. Go. That's very different than like, build me a model that will tell me which ATMs seem to have unusually high withdrawal rates. Check. Done. And business sponsors like, great, I always wanted to know this, but like, great, what are you going to do with that now? You can install cameras on the machines. Like, they're all different. Some of them are 100 times unusual. Some of them are 10 times usual. There's no plan. It's just someone thought they needed to see the most unusually high withdrawal rates on ATMs because it sounds like it's going to be useful. But no one asked the question, what decisions are you going to make once you find out? And the good thing is you can actually mock all this crap up in low fidelity. You can literally make this stuff up. Here's a report of the top 100 ATMs with strange amounts. Now what would you do with this user? And this is exactly what designers do with paper prototypes or low fidelity stuff. We use realistic data, as I talk about, and it's important with data products that we actually design our wireframes or mock-ups or sketches with realistic data. It just means it's fudge data. But the point is we're actually designing a little bit to figure out what needs to be designed. So by sketching out and working in low fidelity, whatever that is, that could even be in Excel. You just hard code a bunch of numbers into Excel and give them this report, and it's just a list of these 100 ATMs with weird numbers. And we're using that and putting it in front of the stakeholders said they wanted this. and saying, what are you going to do with it now? Oh, well, okay, I'm going to put it into this thing and pivot it. And then I'm going to upload it into Tableau, because really what I do is I want to see a chart of when these happen to see if they all happen at the same time. And then if they happen at the same time, then I'm going to call the security department and say, hey, could you watch on Mondays at 2 p.m.? Because it seems like a lot of money gets taken out on Mondays at 2 p.m. Oh, so what you're really trying to do is figure out, is there theft happening at certain times? And like, well, maybe we could just go do that for you and figure out and predict it, tell you when it happens, and maybe get in front of it before it happens. Like, would that, oh, that'd be awesome. But what they started with was, I need a report of all the ATMs with weird withdrawal amounts on it, right? And you can see the trap here. And this is why listening to the customer is important, but you're not there to listen to what they want you to make. You're there to dig into what the problems are. You're there to understand, what have you done in the past about it, to look at past behavior, which is a much better indicator of future behavior. You're not there to build exactly what they asked you for. It's almost always a trap. It's a trap. Okay, you got to pull your Star Cruiser up.
You had a couple great tidbits in here. So I want to start off with the power trio versus power quartet. So in a standard product, so not a data product, a standard, say, software product, we have this power trio of a product manager, a UX designer, and a software engineer.
Yeah.
But when it's a data product, we want to add in an additional person, a data scientist, and that product manager in this quartet might be a data product manager. So we now have data product manager, UX designer, software engineer, and data scientist on this data product development team.
Yeah.
And you brought up a really great point there, which is that this data product team needs to be asking the stakeholder, the user, who's going to be using this data product, given these results, given these, say, low fidelity, as you described, fake results, realistic fake results, how are you going to act? And by going that extra step, you might be able to solve for the real problem that this person is looking for instead of the intermediate one.
Right.
And so you could be spending months devising a solution only to come to having that solution in place and then say, oh, okay, this is great. Now what I'm going to need is this. And you could have just built the
second thing.
Right off the bat.
Yep. I'll also say that doesn't necessarily mean you need 4 bodies, the trio and quartet. What the important thing is, these are hats and they're roles. And you may not have all 4 of the roles, but I think all 4 of those those distinct brain types, perspectives are important to have. And depending on the complexity of the situation, there might be a lot of need for a lot of data science hat on a project. Another one might, it's like software. Maybe it's this model's going to have multiple touch points and internal services, API endpoints, mobile app, website, desktop, text messaging, like all over the place, right? Maybe the UX is really complicated because customers touch it, admins, partners, vendors, roles. Everyone has roles. Admins have this level. I can't see all the data that went into the model, but you can, blah, blah, blah. There's lots of complicated UX stuff. It's just important that these lenses are thought about here. And the other thing is, by having the team work with the customers and the users here, you're going to ask different questions. And this is the idea of like diverse opinions, diverse questions are going to get you more information. Because like if you and I, John, went in and did a project together, you're going to be asking questions that I'm not, and vice versa. I'm going to be thinking a ton about workflow. I'm going to be listening for emotionally charged language that gets people up. I'm going to be thinking about what are the other tool sets to use? How do you do this kind of stuff now? You might be looking at all the stuff no one is even thinking to ask for. It's like, okay, well, like, what if this scenario happens? Or it's like, what if this pipeline goes down and we don't have any customer data? Or what if it's Christmas? Like, we're expecting sales are going to go crazy here. So have you thought about how it's going to happen when we have these normally unusual high volume situations, which are not anomalies, they're kind of expected? Do you know when all those are? Should we be accounting for that in the model or not? Should those just be real blips that we want to treat like, oh my God, what's going on? It's like nothing. You're going to be thinking about all those kinds of perspectives, right? The engineers will have a different thing. The product person could be thinking about, frankly, about marketing, operationalization. How do I get everybody on board? What do I need to do to make sure that all the work that we did actually gets out and gets used, and the business is aware of it? What's the ROI on this? Blah, blah, blah. So again, it's more about, so it could be two people that 50-50 share these roles somehow. Like two of them kind of like one data scientist who's also enough engineer that he can cover all of that person, or he or she, and the designer can also be the product person or whatever,
That makes perfect sense to me. And that kind of thing happens, especially in early stage companies where
Absolutely.
we can't necessarily have all of the roles that we want, and we have to find people that are flexible
Yep.
and who are interested in being that kind of flexible.
Right.
So following along with this power trio / power quartet analogy, Brian, you're not just the founder of Designing for Analytics. You're also a professional musician.
I'm also a customer. That's correct.
Yeah. So you have a professional music education.
Yeah.
And you do professionally. Do you want to just tell us a little bit about it? I think it's interesting.
Sure. Yeah. I went to school for percussion performance. So yes, I get paid to play the drums. I got paid to play the triangle a couple weeks ago at Albany Symphony. So yes, I think I heard, I didn't watch the Super Bowl. So I was like, did you see the ad about the triangle players or something? It's like, yeah, that was me. I literally got paid to play the triangle on one of the pieces. But yeah, I besides the triangle, I do play a bunch of other percussion instruments, and I have a couple groups that I run. So I do a lot of Broadway theater type touring work that comes through the Boston area. Tour with my own groups called Mr. Hose Orchestratica is one of them. I play in a klezmer Balkan party band for weddings and things like that.
That's
Irish music, all kinds of different stuff. So yeah, that's my other life.
Super cool.
Yeah.
Brian O'Neill into Irish music. You'd never believe it. And on top of your Designing for Analytics company and your professional drumming, you also host the Experiencing Data podcast.
Yeah.
So this show, as people would probably suspect, given everything that they've learned about you so far on this episode, it gives a designer's perspective on why outputs alone, so things like machine learning models, dashboards, or apps, aren't enough to drive user or business outcomes with data.
Mm-hmm.
And so you have lots of great guests on the show, people like Tom Davenport himself, to provide a designer's perspective on solving these problems. So the way that you're framing problems that you're describing to our audience today,
mm-hmm.
you're doing that over the course of hundreds of episodes of your own show. So people who are interested in this, and I think a lot of people should be, because designing human-centered data products is key to you as a data scientist or software engineer or business person, having your data product be used and generate revenue.
Yeah, you got it. Nobody wants technically right, effectively wrong, right? Like, I mean, some people are okay with that, but no one that's paying for it or waiting for your thing wants technically right, effectively wrong. They don't really even want machine learning. They don't want analytics. They want decision support. They want to feel empowered. They want business value. They want to get a raise. They want a job title change. They want trust. They want empowerment. It's all this downstream feely stuff. You got to get to that. That's actually where it's at. And it feels weird because it's not about the model, right? But that's ultimately where the value is.
Nice. Yeah, I can see how invaluable you would be in so many data product design discussions. Brian, if people want to follow your work after this episode, other than your own Experiencing Data podcast, how should they follow you or get in touch with you?
Yeah, I'd say LinkedIn is probably the place I'm most active. If you go to designingforanalytics.com, you can find my LinkedIn link over there. My email is Brian, BRIN, at designingforanalytics.com. And I'm a little bit on Twitter, not too heavily involved over there, but feel free to reach out. I've got a mailing list, a free mailing list where I put out insights about kind of this product orientation and increasing user adoption of data products and strategies for that. So,
Nice. Love it, Brian. Thank you so much for coming back onto the show. I learned a ton, and I'm sure our audience did too. I'm sure it won't be long, hopefully not another pandemic, before we need to have you on again.
Yeah, sounds good. Thank you.
Cool. That's it for today's mind-expanding episode with Brian T. O'Neill, in which he detailed how so many data products fail because the user problem being solved was not well understood from the very beginning, how data product managers work alongside UX designers, software engineers, and data scientists to form a power quartet that can develop outstanding data products, and how mocking up results with realistic simulated data enables you to simulate how a user of a data product would react, perhaps enabling you to dig deeper into what the user is really after. All right, that's super helpful and super actionable guidance. I hope you thoroughly enjoyed this episode with Brian. Until next time, keep on rocking it out there, folks. And I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.